Swayam Prabha. Digital India. Educated India.
Welcome to the next big idea. An incredible journey of innovation, passion, and game-changing ideas. Let's see what this team brings to the table.
So let me introduce to my project which I have submitted. So it is focused on producing biofuel. So what's biofuel is that, for example, you have heard about ethanol blending in petrol these days, right? So there is a white end target which our Prime Minister has set that by 2025 we will achieve 10% ethanol blending in petrol, right? So what it helps is reducing our import bill of petroleum products, because in India we don't produce petroleum products. So that is the problem statement that we want to solve here. And the solution we have figured out is through synthetic biology. It's a very brief outlook that I have given. And the team name is Think Global. Why I have thought it about Think Global is that we want to global market for biofuels. That is what I think. So the overview of the project is, so what we want to do here is we want to produce jatropha based oils. So they can be used for almost every purpose that we can employ diesel and petrol these days. So using jatropha as an oil is something not a new idea, right? It has been there 20-30 years from now also. But what we have done is a different paradigm shift in its production way. So traditionally what used to happen for producing jatropha was that we used to cultivate in the jatropha plant in fields, and then the fruit of jatropha plant has seeds, and those seeds produce oil, and that oil is used, right? So I will talk about the challenges which are there in this process and how my solution will help to solve them. So what we have done is we have derived these oils, which are actually nothing but hydrocarbons, by using a yeast, and this yeast can produce these oils. So it's just lipid accumulation in its sense, like the yeast is actually producing lipid and accumulating it inside its body. So by leveraging genetic engineering, we can program the yeast to make jatropha based these oils. The motivation for the problem comes from the fact that from geopolitics actually. So actually what happens is that India faces a very large geopolitical consequence due to our import bill of crude oil. So for petroleum products we are almost dependent on to import all the petroleum products, and that's why that creates energy security, as you can see in the slide. So for example, most of the India's oil come from the Middle East, and in the Middle East there is a strait called Strait of Hormuz. It's a very narrow choke point of 1-2 kilometers width, and almost who controls that choke point controls the whole oil trade in the world. So India and China both face this conundrum. So both countries are trying various ways in order to safeguard itself for its energy security, because as we all know that energy is like the basic thing for development. Without energy you can't have development. So also this project will help us India to achieve its Paris Climate Agreement, that is achieving net carbon by 2070. This will also help in that. So these are the sustainable goals of UN, and you can see them, but more or less they all focus on sustainable growth, like the growth not at the expense of environment. So what is the problem actually? Good supply of energy at cheap prices without having to face environmental consequences. So what are the major sources of power we have today, energy we have today? First one is oil, petroleum products or fossil fuels in general, even coal comes into that category. What's the problem is that they are polluting. Second, they are exhaustible, right? They are not renewable. Like we will exhaust Earth with these resources one day. So we have to follow for some alternatives, right? Then we have solar, which is very promising, but it has its own demerits. First, the cost of production of solar, by the way, it is decreasing, so it's a good thing. But not only the production is the issue, but the production capabilities of India in solar is not very good, because these are basically nanofabric materials, we use silicon, and those fabrication techniques, advanced technologies, India does not possess. We almost import these technologies. Second is the maintenance of solar panels. Like they have to undergo regular maintenance. And the most important problem with solar panel, which nobody realizes, is proper handling of discarded solar panels. So solar panels have approx life of 10 years. So after 10 years, the issue of decomposing these solar panels become an issue, right? So we are in the first place want to achieve sustainable growth, but these solar panels actually are hazardous, right? It's the same problem faced with nuclear energy. That the nuclear waste we cannot dispose it of properly. I have not figured it out. Second is the EV. So EV, the main problem is energy density. So for EV we use lithium ion cells, lithium batteries, which is like, this is a very new novel invention which has increased the energy density of electric vehicles, by the way. But still now the energy density of electric vehicle is very less. So for using in all purposes electric vehicles becomes cumbersome, because as you increase the weight of the battery for increasing the range, the weight of the car itself, the automobile itself increases, and that creates problem. Third is green hydrogen. So there are various kinds of hydrogen, we all know: pink hydrogen, grey hydrogen, blue hydrogen, green hydrogen. Green hydrogen we all promote because it's based in a sustainable way. What we do is we electrolyze water, we produce hydrogen and oxygen, and it gives largest energy on combustion. What is the demerit of using hydrogen? First is we haven't figured out how to transport and store hydrogen. Hydrogen has molecular weight of 2. And because of that, if you studied in class 11th, that for every mole of gas at STP, if you store it, which is by the way 0 degree, 273 Kelvin, you require 22.4 liters, right? So 1 mole of hydrogen is just 2 grams. So for 2 grams, storing 2 grams, we need a container of 22.4 liters. Can you imagine? Container of 22.4 liters just to store 2 grams of hydrogen. And thus we are forced to compress it down, and this compression uses energy. The second problem is production requires huge amount of electricity. As I told you that what we do for the production of hydrogen is we electrolyze water into hydrogen and oxygen, and we use hydrogen, by the way. So this electrolysis consumes a lot of energy. It's around 431 kilojoules per mole, right? So this is, by the way, the energy that we are using to produce energy, right? By the way, it's electricity. So what's the meaning of then producing using hydrogen, right? This is a major caveat here, and other is the infrastructure, which is not available these days till now, and we require huge investment for it. The third major source can be wind. Wind is a very excellent source, cheap, but it's unreliable because every place doesn't receive the same amount of wind. The wind is not predictable, so it causes maybe energy power cuts. It can cause. So we cannot rely solely on wind, and India has not very windy country. So solar is promising for India, but wind is not. So what the problem this is that we are forced to use fossil fuels. So Indian government, here are data, it spends $130 billion for just importing crude oil. And by the way, this is the last year data, and this year the bill has increased, by the way, right? It's like, I think it will cross 200 billion soon. So this is a huge pain in the pocket of government, right? To spend a forex reserve that we because our total exports is 400 to 500 billion, so it's 40% of that value. 85% of the Indian crude oil is imported because India is not an oil producing country. So this gives geopolitical leverage to oil exporting countries. By the way, they're just OPEC countries. And this is why we are forced to have a good relationship with them, right? We can't dictate our own terms completely. This also impacts Indian energy security. So the Indian government saved 45,000 crores this year by implementing ethanol blending. So this tells us the psychology of the government that it also want to find an alternative. And ethanol, by the way, it's also kind of biofuel. You can put paraphrase it like that. So India is the 4th largest consumer of energy, and our energy sector is huge, and this gives us the estimate of the target market that we are addressing. And the solution is biofuel like jet fuel. But there are problems with using jet fuel. It is the production which is a problem. So the low yields of the farm, the land grabbing and mismanagement, land use conflicts in farms, the lack of domestication. So this is the wild species that we use. The high cost in oil extraction, which is, by the way, very great because the oil content in jet fuel is very less. Then there are technical challenges in producing, but the major problem is Jatropha plant produces toxic elements, which by the way degrade soil and it's toxic, right? So that is a major drawback. So how can we produce Jatropha by not relying on the farm? And here is the solution. It's by genetic engineering. So what we have thought is that we will use a yeast species for genetic modification. So we are going to insert the genes of Jatropha into yeast and produce biofuel. So this is you can see the process of producing biofuel by using this method. First is the genetic modification step, which I told you, introducing a gene of Jatropha plant into yeast. The second is the pathway engineering, where we pipeline the product. Third is selection and screening. The fourth is fermentation. We finally ferment it. And finally is downstream processing, which is purifying it in simple words. ये जो हम करना चाहते हैं, yeast का सेल है, इसमें हमने जीन इंसर्ट किया है और ये जो है वो हाइड्रोकार्बन्स प्रोड्यूस करेगा, लिपिड्स प्रोड्यूस करेगा. ये जेट्रोफा का फ्रूट है, इसी में से ऑयल निकलता है, बट हम yeast वाला सोल्यूशन यूज कर रहे हैं. हाँ, so innovation is this. You can see it's inserting of the gene in the plasmid of yeast so that it will express those genes and produce hydrocarbons. What are the uses, potential uses, where we can employ this? First is in the automobiles, diesel generators which we use to produce electricity, and the major application we are finding it out in airline sector. So in 2018 what happened is that a SpiceJet flight was tested with Jatropha biofuel and it functioned successfully. So the proof of concept is already there. We just need to scale it, and for scaling we have employed genetic engineering. So what is the value proposition? So as you can see, first is a reduced environmental impact. Second is it's sustainable because it's renewable, because it's not like oil that we are extracting it from the ground. Third is high quality hydrocarbons. So if you are using the plant, we cannot control the quality of the hydrocarbon which is produced, but through genetic engineering we can, because we have all those pipeline processes and finally the downstream processes which we can control the quality. Next is to use in the biofuel industry, in the lubricant industry also, and in the chemical industry also. So we can use this approach. It's a common approach using genetic engineering. So we can make some other kinds of chemicals, biochemicals, using this approach. So what's the market we are estimating here? So we know energy market is huge. So I cannot say the TAM is $5 trillion or $10 trillion, which is, by the way, the energy market of the world. So I am taking a rough estimate of $400 billion. So how I came to that estimate is that $200 billion is the market of $250 billion, by the way, is the market of airline fuel. And we will try to dominate airline fuel category, and other can come by various applications that I told. So even if we cannot include automobiles as a sector, this $400 billion can be reached. But obviously this is not the market share of one simple company. So we are looking at a serviceable addressable market, which I estimated to be $10 billion. And the obtainable market, because if this thing takes off, there will be a lot of competition. So that I estimated to be $1 billion. What is the target market? It's the energy sector. The first we will roll out for airlines and diesel generators. Then we will go on to different categories, dominating different categories, and finally we will try to go for domestic fuel, because heading straight into for domestic fuel or maybe using in automobiles will lead to large scale competition, and that we are avoiding. So we are starting with a very niche market, and then we are planning to expand further. So the competitive landscapes. So who can be the potential competitors? It's all the combined energy sector, which I told you ago, all the renewable or the non-renewable sector. The barrier to entry is here the IP. So if we get patent of this technology, we can build a barrier to entry. So what I am thinking of, if we get further with this project, we can do backward integration, and it will help us to control the cost. Revenue streams can be through product sales of the fatty acid hydrocarbons directly to the customers. Even to the B2B we can practice. Then technology licensing. So if we can't produce it by our own, we can license this technology to someone else who can produce it, and he will pay us royalty. Third can be R&D services. We can offer R&D services which we will develop expertise, by the way, selling intellectual property and patents. And further can be government and NGO grants. and what I have estimated the selling price of Jatropha would be 65 to 75 rupees per liter. So by the way, in the market currently Jatropha is not used. So I have talked to some vendors, they say it costs around 80 rupees per liter, but we are planning to get 65 to 75 rupees per liter, and this will create good profits. So this is our team. I am Anshuman Rawat, and here's my fellow friend who is Swapnil. We both are students of IISER Pune, and we are pursuing BSMS, majoring in biology. So I am also pursuing the CFA course, by the way, side by side, to build my some knowledge of finance, which will help us. And Swapnil brings us with some expertise in web development, so he can build a social media and digital presence, by the way. I am also keen interest in psychology, which will help us to understand consumer behavior and employ further tactics. So these are the strengths we come up with, and this is the team. So I want to thank you, and I want you to grab this opportunity to revolutionize the energy sector by the way of genetic engineering, making Jatropha and solving this huge problem. Thank you.
Thank you so much. Okay, very first question. According to you at least, with this one currently, are you at a product stage, a project stage, or you're trying to figure it out?
I'm, put it blatantly, I'm just trying to figure it out. Okay. So it's between the ideation and the project stage. So it's not in the product.
You want to pursue this ahead as a product as such?
Yes. No, it's between, we have ideated it and we are trying to go for the project stage. We will be working in laboratory. So we have contacted some professors in IISER, and we will work with them to employ this project, and product stage will come later. So it's a very early stage, this idea is.
But at least are your formulas established, the ones that you mentioned on your slides? Are they things that you expect it would work, or is that something
that you there are two parts of the thing. Jatropha works, we know that, because in biofuels we have tested by SpiceJet 2018. SpiceJet tested Jatropha fuel for without any engine modification, by the way, and the flight was perfect. So Jatropha works. This concept using genetic engineering, there could be problems, by the way, because we haven't gone to the product or the project state completely. So there are challenges ahead. So I do acknowledge them.
Okay, agreed. So whenever you're in a stage like this, right, I appreciate the idea and appreciate the way you've put things through. But one thing, you focused on the problem statement in your very initial slide. The focus was so wide and elaborate that at a point I lost where are we headed to. So another way you could put this is, you explain your issue that okay, use of fossil fuels and traditional fuels is my issue, right? What is the issue there? That supply chain could be the issue, geopolitics affects your supply chain, the cost and sustainability are problems, right? Now your alternate fuels that you mentioned, that okay, options are EV, then hydrogen, then clean fuels, etc., etc.
I was trying to counter demerits, because we have to demerit.
No, I understood that. I understood your point and agreed. These are information that you should have for very sure, right? So that's the thing. You research for years and then you have to present the whole thing in 5-10 minutes. So that's your skill as to how and what do you present in that 5 to 10 minutes and what should you exclude, right? How does an EV market work and what are the pros and cons? A lot of people, the ones that you present to, would already know about it. Fossil fuels are something we've been learning since our childhood, what are problems with it, right? So just focus, had you been focusing more on your solution part, that okay, this is what I'm expecting, this is what could happen, this is what could go wrong. So that gives more confidence on you as to what stage are you on.
Okay,
Got the point?
I will implement this feedback.
Okay, good.
Have you figured out that for a production level, what is the raw material and how you are going to tackle that?
Okay, so it's actually cultivating in the lab that yeast strain which we were talking about. Raw materials are all those lab products that we use in the lab for incubating yeast cells. The normal biotech products that we used, like selectable markers, restriction enzymes, and plasmids, vectors, all those things we have to use.
Okay, as you said, it's in a laboratory. So, are you sure that the production scale of the production will fulfill the requirement you are comparing with?
Yeah, that is the only problem we are addressing to produce mass scale. So, as we have seen for insulin, for example, I would say, insulin was produced in a different way. We take animal insulin, extract from animals, and then you transmit in humans. that was not a good approach. Genetic engineering was a good approach there, that producing insulin, transmitting the gene of insulin producing cells from human cell and transmit it to the Escherichia coli bacteria, and then we mass produce it. So now insulin is so cheap is because of this technique only. So this is actually the proof of concept that this has worked for many products. It's not something very innovative which we are trying to do.
For a market, what is it will be cost and what will be the range?
Okay, so it will be very difficult to estimate costs at this moment because it's a very early project, I will admit that. But what we are saying is that the cost will be definitely lower than what cost Jatropha is presently, because of these problems that I told about cultivating Jatropha plant, that it's poisonous. The yield of oil is very less, so we require a lot of energy to extract oil out of it. So because of that, this process could be scaled very much. It's a scalable process, right? Cultivating plants on land is not scalable, right? Tech is highly scalable. This is also scalable, but in between them, not highly scalable as technologies.
Okay.
So as we scale more and more, obviously the cost will go down.
Okay. One suggestion for you as a presenter, right? You should know your disadvantages very well. Excellent. But every moment it is not necessary that you explain the disadvantage, because that lowers my confidence in you. Your disadvantage is your issue to be worked out in the background. Agreed?
You're working for a good cause. Keep it up.
Thank you.
And now it's time for judges' opinion about the pitch. So, it was a good one.